From Fresno, it's Go Programming. All right, follow that intro.
So this is the program we were working on, and here's a version of it that does everything we were talking about. So I just saved all these constants for the conversions. Okay, so feet to kilometers, feet to meters, feet to miles, and so on. And then this is the same thing we've been doing. What I did is I pulled the result out into its own variable, and that way in our switch statements we just assign the result in all the cases. And there's 16 of them. And then you finally just print the result at the end. Pretty straightforward. We could add defaults to all these, unknown from type, unknown to type, or whatever. But pretty straightforward. We're going to see in a second a better way of writing code like this. Like when you see this, it's like, oh, maybe I'm doing something wrong because it's so much extra code. Right? And but anyway, pretty straightforward. Hopefully everybody got that. Any questions about that?
Yeah. The statement you just made, Caleb.
Oh.
My question is, in your experience, extensive as it is, or anybody else's in the classroom, is there always a better way?
No, there's not always a better way, but there usually is.
Okay.
Yeah.
I just been wondering because it seems like there's always a better way to skin a cat.
Yeah. Sometimes you'll find examples in the Go source code where there's a lot of, if I go to syscall, this is like a library that is like everything in your system that's not really exposed for you to use, but is necessary to implement things. You'll see giant things like this, right? It's just like every constant your operating system defines listed. And there's really no better way to do this than just to list them all, because they're all there. So sometimes it is just terrible.
So a follow-up question.
Yeah?
When you write something, create something, where do you get feedback so that finally you yourself have come to the judgment to say, this is the best and most streamlined I can get this, I'm ready to put it out there? Is it off of GitHub? Is it just conversing with fellow colleagues?
Yeah.
Respected colleagues, is that the best way to go about?
So the first thing you should always, the important metric as far as your program, sort of two things. The main thing is that it is correct. This program is working, right? That's what matters. So, if I compile this and run it, does it do what it's supposed to do? Because if you don't get that right, everything else doesn't matter, right? Development, programming, it's the business of making something else, and we're using programming as the tool to do it. And so you should always keep that as your focus. If I'm making a web application, I have clients, I have users who are going to be using that web application. What they want is my primary goal. Now, how I achieve it is up to me, but the focus should be on that it does what it's supposed to do. Then as a secondary is that it does it in a way that is good, right? So it's fast, maybe it doesn't use a ton of memory, like those kinds of things are important too, okay? And then once you've gone beyond those two layers, you start to get into this other layer of, well, is the code the way I want it to be, right? And as far as how do you get feedback there, most companies do code reviews, they do things like that. You gain just by, there's a lot of books you can get and practice, you get better at it. And there's a lot of ways you can do that, but like I said, when you see a giant switch statement like this, it puts up a red flag of like, wait a second, I should almost never see something like that. So am I doing something wrong? And it turns out there is a better way to do this. You're right, sometimes there's not a better way to do it, but usually there is. So we'll see that. Any other questions about this?
Just a general question. Is there one of the build tools that we saw when we were working in JavaScript for Go? I mean, is there anything like it? It seems like we're doing a lot of back and forth. Is there anything like Gulp that will actually take that code and push it right out without you having to do anything?
Yes. So when we use App Engine has that ability, the live code reloading. So we'll see that. But you get used to it pretty quick with just, it's 2 steps and it's not bad, but yeah, so App Engine does do it for us.
Okay.
App Engine has its own version of Go built into it, and it can do it.
Can you go back to that web page real quick?
This page? It's godoc.org/syscall. Like I said, syscall is like a library you don't typically run into, but it's used internally by Go for lots of things. These are all the like built-in functions of your operating system.
It's 2 L's.
Yeah. So syscall also is the library that's radically different between operating systems. So the one for Windows is nothing like the one in Linux because they're not the same. So, okay. So we can move on to the next topic. So this is new material. Everything we did this morning was old material. There is an extra problem here, which maybe we'll do, but we're not going to do right now because it's hard and we should learn something new today. So I want to talk about arrays, slices, and maps. So we saw the basic types, and these are things that use the basic types and they're more complex. So first we'll look at an array. All right. So an array is a numbered sequence of elements of a single type with a fixed length. Okay? So the idea of an array is if I have an integer, that's a single number, right? I could have 2 integers, and that's an array of integers of length 2. Okay? So the important thing about an array is it has a fixed length. So when we see this bar x, and then in brackets, square brackets, we have 5, and then the int. Okay? That's an array of length 5 of type int. So 5 integers, and they'll all be right next to each other. Okay? Are we following that idea?
Yep.
So remember I said it has a fixed length. So arrays are different than they are in JavaScript. In JavaScript, an array, you can push onto it and it can grow, right? The other major difference is that in Go, the array has a single type. It's integers. You can't have an array of integers and strings, okay? It's not quite true, there's an exception, but we'll look at it later. But basically, you can't do it, okay? And so, how do we use arrays? Well, here's an example program. I will paste that into a new folder here. Arrays. Ooh, maybe I should call it that. That's okay. I don't think there's a command line app called arrays. Don't make a folder called ls or cd or just suggest it.
Is this a serious limitation that the array has to be, all the elements in the array have to be the same type?
They do have to be the same type. It is a limitation. I mean, you can think of it as a limitation. There are, like I said, there are ways around it, but okay. So arrays. We'll see that later. And actually, the slices we'll see in a second too, which change some things too. But so we have our array. We created it. It's called x. It's the length 5, and we can use, just like we do with strings, we can access an element of the array with the brackets and then the position, right? And so we made this array and we set the 4th one to 100. Okay, and then when we printed it out, we saw that 0, 0, 0, 0, 100. It's because we didn't set the 4th one, we set the 5th one, right? Because we count from 0. But notice these are all 0. That's because their initial value is 0, right? Because integers are always their 0 value 0. So if I create an array of a huge number of integers, they're all going to be initialized to 0. Okay. So that's what we saw. We saw that, and so all that's working. We can also do it this way. So here's a function that we're using to create arrays. So let's try that. Okay, so now I've set all of the values in here. So 98, 93. Imagine this is like test scores or something. And then we want to calculate the average. Okay, calculating student's grade or something. And so you start total to 0, and then you loop over. We go 5 times, right? So we create our for loop, and we start at 0, 0 less than 5, and then we add to the total the element of that one. So, and then we divide by 5 at the end, right? So what's our answer when we run that? 86.6.
Just guessing.
So that seems right? I mean, that looks like a good way to be. And so you understand the basic idea here. So when we do the bracket I, we're getting that element from the array. So this is 0, so we first get that one, and then we get that one, then we get that one, then we get that one, then we get that one. Okay? And this is a very common way to use arrays for this kind of, oh, I have a huge number of things, and I want to do something to all of them. Right? In this case, we're calculating the average.
Caleb, can you just control Z real quick, just so we can see the example for it real quick, and comparison? Okay.
All I did was set more and then run this total.
How would you use, if you're willing, do a tangent, a range to loop over that? Just curious.
Yeah, we'll see that in a second.
Okay, no
I
worries.
just wanted to mention that, first of all, the problem with this code, this 5, this is an example of where things, you're like, wait a second, I see a 5 here and a 5 here, and a 5 here, right? So you should probably use length here. Okay. Right, that's the idea. Now notice it's giving us an error. You can't read that error, but what it says is invalid operation, total divided by 5, mismatch types, float 64 and int. So when we did 5, 5 is a number that can be an int. That's like what it will be by default, but it can also be a floating point number. And Go will automatically choose which one based on context. So when I took a floating point number divided by 5, it said, oh, 5 must be a floating point number. But when I take the length, length is an integer, okay? And I can't divide a floating point number by an integer. I have to convert it into a floating point number. So you end up having to do this, okay? I think we saw that yesterday. So I convert integer into a floating point number and then divide it. And this should do the exact same thing we saw.
86.6. Oh.
You put the integer into a float or something? A float. Wow.
I converted an integer to a float. But now I can increase the size. I don't know what the last score should be.
How is that line doing? Isn't it already a float from the declaration?
When you take the length, length is always an integer.
Integer, okay.
And now it calculates. I didn't have to change my loop, right? I didn't have to change this or this. I just had to change this and it worked automatically. So that's better. It's better to have the length. But you're right, we can also do the range. So if we look at the spec on range, we can see that it's a range. Yeah. See, it says range expression, array or slice. So let's try that. So we have total for and then our array next. And we'd say total plus equal v. So it turns out if we do it this way, I and v here, I is the index, v is the value. We don't need I because we're not using the index, so we can just do it this way. And so that is a little cleaner, and this is a preferable way to write this kind of loop. If you want to loop over the whole array, use the range. Okay. If you only need to do a part of the array, then use a regular for loop. But if you want the whole thing, and especially if you don't need the index, then do it this way. Okay. Any questions about that? Pretty straightforward. It's basically the same as a string. And so actually the string is basically an array of bytes. Okay. Basically the same. Okay, back to. Okay, so we made this change. We saw the float 64 error. We saw the conversion. And now here you can see the range. Same idea. There's the underscore. Okay, so we can also create arrays this way, because like this is kind of tedious. So you can create them in with this format. So instead of having all of this, I can say equals, and then use curly braces, not brackets. Never remember the whatever. There's a way to do columnar selection. I can never remember how to do it. Okay. And that's cleaner, that's better, because now you don't have to have the indexes, they're just implicit. And pretty straightforward. So you can create an array with this syntax, okay? Everybody following?
Do you have to say that the array is a slice?
Yeah. Yeah, basically, because it's an array, it has to have fixed size. I think there is a way to, let's go look at it. I mean, it turns out in Go, it's actually not typical to use arrays all that much. Use slices, which are like arrays. We'll see them in a second. But yeah, you have to have the length for the array. But yeah, so you can do the shorthand syntax, and then you can, it makes it easier if we want to get rid of one or whatever. Okay, so that's arrays. You can index them, you can loop over them, you can change them. Unlike a string, you can change an array. Okay, they can have, this type can be anything. These are floats, but they could be ints, they could be other strings, they could be other arrays. So maybe I should show you what that looks like. If you want to create a multi-dimensional array, like a matrix, you could have like that, 4x4, and then one neat thing about Go is it allows you to elide the type, where you can remove it, and so you don't have to repeat yourself. And so it actually kind of looks like a matrix, which is nice. I think this should work. Okay, let's see if that works. Yep, there's our array of arrays. So it's an array of arrays, which is how you can make a multi-dimensional array, right? And so the way you access things with that is if I want, I do it that way, okay? So it's like, get the first element, that's going to go get this guy, and then get the second one, that's going to get that guy, okay? Following? So you could think of it like rows and columns.
Say that last part again.
Yeah, so the one here gets to the first array,
Array.
and then the two here gets to here.
There.
Because 0, 1, 2. Yeah, I don't know how often you run into this, but sometimes I see it. But it can get a little confusing when you see the types, right? They start to add up. And you're like, oh man, it's getting kind of complicated. But so this is a big difference between Go and most languages in the C family. The types are in the reverse order, okay? For a lot of these things. Like it's var x and then a type, and like C would be the type and then the name. Right? So some of these look backwards to people. But that's the format they're in. Okay?
You said that strings are not adaptable?
You can't, they're immutable. So you can't change them. But you can change an array. I can say x. Like that's perfectly fine. You can do that. Okay. Now when we saw memory, remember we talked about memory? You can think of RAM as a giant array of bytes, right? That's basically what it is. I mean, really, really big one. And so when you store this kind of object in memory, that's what it's going to be stored as. Okay. It's going to be stored as float 64 here, and then here, and then here, and they're all right next to each other. Okay. They're all contiguous. If you ever have to know that, that's what they would be like. Okay, so like I said, we don't typically use arrays directly. Instead, what we use is called a slice. Okay, so a slice is a segment of an array. Okay, so they work almost exactly the same way as an array, but you can make them grow, so they don't have to have that fixed size, and their size can be sort of. You can also make them smaller, so you can, like we saw with strings, you can select a piece of that slice, and you can do that with slice. And so, how do you create a slice? You leave out the length on the array. So, oh yeah, I have to use it. So I've created an empty array or slice of float 64s, and now I filled it, now it has length, okay? So this is a slice, not an array. The difference is there's no length. If I put a length in there, it's an array. If I don't, it's a slice. Now it figures out the length. The way this works is it creates an array, and then you can think of a slice as having 3 components. It has, it has a pointer to the array itself, and then it has a thing that says where to start in that array, and then it has a thing that says how long it is, okay? So you can think of it like, I have an array of 1, 2, 3, and I'm pointing to the very first element, and I say there's 3 of them. Now I could have a slice of bytes, so I could have a, like, y colon equal x, and then I could say, like this, right? And so, what is that going to print? So I created a new slice, right? And I'm starting it from 1, and I'm selecting to the end.
Number 2 and 3.
Exactly. So when we run that, x has 1, 2, 3, and y has 2, 3. They actually are put into the same array, okay? So x and y are the same array, just a different piece of the array, different segment of the array. That's important because you could have a really huge block of memory and use slices all over the place without copying that memory. Okay? So slices are, that's why we generally use slices more than we use arrays, just because they make that whole process a lot easier. And we can do these nice things. So there's basically no extra cost to using a slice as opposed to an array. That's the other advantage. We can use them just as if they were arrays, and everything works exactly the same way. But when we need to, we can expand them and use piece of it. So in addition to this syntax, the var x equal and then the expression, you can also use make. Okay. Go has both a make function and a new function, which is a little confusing for people. So we're going to see an example of make. You give it a type. Okay, so I'm giving it a type of slice of float 64, and then a length. So 3. Okay, and that will create a new slice of float 64s that has space for 3 of them. They will all be initialized to 0, and then you can set them just like you would before. Okay, everybody following what? So this second example is as if we had done this. Basically the same thing, okay? Those 2 things, basically the same. The second one is useful when you want to create something of a certain size, but you don't really care what's in it. Because what if this were, 3,000 or whatever? You don't want to have to write all those zeros. And so it's nice to be able to give it a size. And it turns out, you might think, well, why in the world would you create this huge array of 30,000 doubles or whatever? Why would you do that? When it comes to using bytes, like a slice of bytes, we do that all the time. Because the data that comes over the network comes in as a slice of bytes. So not unusual at all to see numbers that are very large for that. So you would do it with make, is what I'm saying. Okay, so you can use make or you can use the direct. Make has a second parameter that it takes. So we can give it, so if we had 10 and 15, and that's the capacity. Okay, so the idea here is that I have this array, right, and I have a segment of it. When I use make like this, what it does is it creates an array of length 15, and then makes the segment go to 10. So there's 5 extra things at the end, okay? It's not very often that you need to do this, but sometimes it's useful. Because when you add things to a slice, it can grow into that extra space. And eventually, when it runs out of that space, it has to create a new array and copy everything. So sometimes it's useful to set the capacity so that you don't have to worry about that. Like, it's more efficient. If you know ahead of time, I may need this extra space. But pretty unusual. Generally, you're just going to set the length, and that's fine. Okay? So this is the idea with you can see the little blocks, right? X is pointing to this part of the array. And we saw this example and we saw this. So pretty straightforward. So there are two functions we use with slices, and those are append and copy. Okay? And so append adds things to a slice.
Caleb, can you go back to the text a minute? Back up there, yeah. Up a little more where your diagram is. Is it? So the 5 there designates the segment, correct?
That's right. So the length of x is 5.
So it doesn't index from 0, that value does not index from 0.
It does.
Yeah.
So this is 0, 1, 2, 3, 4. The total length is 5. And the capacity is 10.
Okay, so it does the length.
So there'd be zeros in the first 5 positions.
There'd be zeros in all of them, actually.
And all,
Yeah, because it always initializes the memory.
okay.
Unlike C, you'd end up with whatever happened to be there before.
So this just designates X as those first 5 positions.
That's right.
Still initiates.
So that statement is making an array and a slice?
Yeah, when you make a slice, it creates the underlying array. So.
Caleb, Eunice has a question.
Yeah.
Yeah, I saw one example there that has some value in between the braces. Does that mean like, so if we say let's
This?
make between braces we have 5 float 64 and then 10, does that mean like 5 arrays of that?
Oh, no, you can't do that.
Well, I saw it in one of the examples in the document that you were in. Go down. Right there.
Yeah, see, we're not using the word make here. We're just creating it directly. This is how we make the array.
Okay.
But for a slice, you can use make, or you can use just leave out the number.
Okay. So when you use make, you just leave that out. Or empty.
Yeah, exactly. You leave out the length here.
Okay.
Because it comes from this, right? That's telling me.
Cool.
Yeah. Oh, that's another thing with the array. You can convert an array into a slice using this operation. Okay. So a trivial way to convert an array to a slice is you have, like, this is an array of 3 elements. You can just say like that. Okay. So no starting index, no ending index, just give me the slice. Pretty rarely you need to do that, but sometimes you do. Because normally you're working with slices, so you already have a slice. Okay, so like I said, there are 2 functions we tend to use with slices a lot, and those are append and copy. So I'll show you an example of append. So say we have 1, 2, 3, and we want to add 4 to the end of our slice. So like I said, arrays have fixed size and slices can grow. And the way they grow is you say this. You say x's equal append x's 4. Okay? And that's going to append to the end of x's the number 4. So if we show it before and after, we should see 1, 2, 3, and then 1, 2, 3, 4. Okay?
And in that case, it's not the position, it's just the next number that it's added.
Yeah, because the append puts it in the, we had that segment, it's going to put it in the next one, if there is a next one. In other words, every slice has a length and a capacity, and if the length is less than the capacity, it'll just insert in the next one and make the length a little bigger. And it'll keep doing that until it hits the capacity. Once it hits the capacity, it's like, oh, I don't have any space left. And then it's going to create a brand new array and copy everything over to it, and then append it. Okay? And the way it uses it is basically it doubles the size of the array each time. Okay? And that's just an efficiency thing. It makes it more efficient. Because copying can be expensive, all that copying of the memory. So, but that's an efficiency thing you don't generally have to worry about. Like I said, you can just use append because it basically does what you want it to do. And so this is how you can do like push in JavaScript. You can do it, use append and go. Notice the pattern though, you have to assign it, okay? Because this can change when that copying thing happens. So you need to assign it. X is equal append X is 4. You can append lots of values just by adding them to the end of the list, okay? So 4, 5, and 6, 7. If you have a...
So it replaces what is in memory for S, is that what you're saying? So whatever it reserved in memory in the first line in line 6, it reinitialized in line 8?
Right, So it's as if we had, 1, 2, 3, and then x's was pointing to this, right?
Right.
And then it said, it tried to put 4 here, and it's like, well, I can't put 4 here because I've reached the end of the, so it created a brand new, and it probably doubled its size, okay? And then it put 1, 2, 3, 4, 5, 6, 7, so on. And so maybe it has a bunch of extra empty spaces over here that it created, expecting you to append again. And now x's will look like this.
Yeah. Yeah, that's what I was asking.
Yeah. Everybody following that? So it like copied it, and then it just copies everything over and then it has it. So it usually does what you want it to do, so you usually don't have to think too hard about the efficiency. Yeah.
And if you ask it to append more than double it, does it append again and show 3 lines, or does it just show 2?
So it knows how many things you're sending it in, so it can figure out how much extra space it needs to add, because it can know that at compile time, because you have it right here. If you were going to do another append, it might involve a 3rd copy, but it would only print twice though, because there's only 2 prints here. And that's just happening behind the scenes. All you need to know is that it's creating a slice of this certain length. It may or may not be the same slice. It doesn't really matter. All you care about is that you added it to the end of the slice. Okay. The other one's copy. So the other function is copy. And these are built-in functions. You don't have to like import and then. So we can copy. If I make oops, of ints, I want to make it 3. Let's make this interesting. 4. I can use copy. Okay. And the way this works is, this is the destination, and this is the source. And it copies everything inside here into here, okay? And overwrites whatever was there. So the interesting thing about this is it only copies up to the length of the smallest one. So if this is 4, it'll copy into here 4 of the values from x's. X's has 1, 2, 3, 4, 5, 6, 7. So it'll only copy in 1, 2, 3, 4 into y's. That's what we should expect to happen. So let's see if that happens. Right? Because it's like 4, so it only copies what it can and just leaves everything else out of it. So we use copy a lot with slices for this reason. So a trick you can do with copies is something like this. What is that going to do?
Second position.
Yeah, so what do we expect to see printed at the end here for this?
3 and 4.
Okay, let's see if that's what happens. Does it make sense what happened here? What we did is we created a new slice that's just this piece here, this one, the last 2 of that y's, and then we copied from this one into that one. And so it took these and put them here. So in Go, you'll often see code that looks kind of like this. It's a little backwards maybe from what you're expecting. You're expecting to be like, copy into this location, and then take it from this place. But instead what you're doing is you're changing the slice and then using regular copy. Okay? And that can be a little confusing for people. So I just want to make it, this is like taking a piece of that original slice, and then you can modify it. And that's what we do with copy.
Slice is more like a view of the array rather than
Yeah.
anything by itself. Then.
Yeah, it's like, yeah, exactly. A segment of the array. So you'll often see this kind of done this way. One other thing, since we have this y, is what if we wanted to take, if we had, we wanted to append all the values of y's to x's. The way we can do that is we can use this dot, dot, dot. Okay? So basically, this is going to take everything that's in y's and add it to the end of x's. That's the dot, dot, dot. So there's the distinction between a single value and multiple values. For a single value, you just put it. For multiple values, you use dot, dot, dot. Okay. So if we run that, we add 8, and then 3 zeros because it's of length 4 and they're blank. Make sense? So what if we only wanted this one? We didn't want to add those 3 zeros. How would we do that?
Instead of dot, 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 you just put 8
Right, but
on 1 or 0.
you mean like that?
Yeah, yeah.
Okay. So, right. Now what if we had, and we wanted those 2? Right.
You go 0 to 2, 0 to 1.
Right, so one way to do that would be this, but what's a better way of doing that?
0, comma 1.
0 to 2, colon.
You mean like,
Yeah.
and then, okay? All in that? Yeah, so once you get used to the slices, you start to play with them, you're like, oh yeah, I guess you can do it that way. So, we take y's and we slice it down to here, and then we append that, okay? So that gets our 8, 9. And not the other 2 zeros, because we only include the first 2 of y's. Okay? Python has a similar idea. But it does take some getting used to the subscripting. So those are append and copy. Or I didn't, yeah, I should copy. And that's basically enough to make you be able to do almost anything with arrays and slices. So it's surprising that in addition to length, which we've already seen. Surprising that you don't need a lot more than that to do more. Everybody understand slices, what a slice is? We're going to do some example problems that will hopefully, you'll start to get a better feel of them and how you use them and why you use them and stuff. But I just want to show you all the bits there. So the last part of this section is maps. You guys used objects in JavaScript? Maps are basically the same kind of thing. It's a dictionary, or a lookup table, or a collection of key value pairs. Okay? It lets you look up something by something that's, so if we have an array, right, we can go to the nth element by using a number. But what if we wanted to have a string, right? I wanted to look up a word in the dictionary and get its definition. Well, an array doesn't really work for that, okay? And so we can use a map to do that. So it's an unordered collection of key value pairs, associative array, a hash table, a dictionary. Maps are used to look up a value by its associated keys. So you create a map with this syntax. You say var, the name of the variable, and then the type is map, and then in brackets, the key type, and then outside here, the value type. So this maps strings to integers, okay? So if I want to look up a value in x, I have to use a string as my key, and it's going to give me back an integer, right? So here's an example. Let's run our example here. That's a fun error. So we have our map. We set the key here, which is a string. This could be anything, right? You know, it doesn't have to be the word key. It can be anything. Just a string. And then we assign it a value. This has to be an integer. So the key has to be a string, the value has to be an integer, and we're assigning it. Okay? We're putting something into our map. The reason why this throws a panic, why this panics, is because it's a nil map. So we have to initialize the map here, okay? And so normally you're going to write equals, like we saw with the slice, make map of string again, okay? Now, unlike with a slice, you don't have to give it a length. It'll just default to 0. And this should help. So, it's a map. It has anything inside of it that maps to 10, okay? So we can access anything by doing this. Okay? So it looks just like the way we use the slice, except now our keys are strings. And this is, what does this give us if I run this?
10.
Yeah, exactly. Gives us 10. Because we looked up the string, this key has to match, right? So if I, have something else, it's not going to match, right? It's going to give me 0, which is kind of surprising, right? But maybe it's not surprising. So you have, this key doesn't match this, so I don't get back that value. So why do I get back 0?
Because it's still shrinking to. Is that the default return for a computer?
It's because the 0 value for an integer is 0. And this is a map of string to int. So if I have it and it's inside of it, it gives me what the value is. If it's not inside of it, it gives me the 0 value. So since integer is the 0 value, 0 gives me 0. So then the question is, what if I want to be able to know if it's in there or not, right? Because what if I had equals 0, right? And now I can't tell the difference between these two. When I run something, I get 0. When I run something else, I get 0 as well, right? Even though this one isn't even in the map and this one is in the map. So the way we can tell the difference between the two is there's a special syntax that it returns two options. So we can say v, okay. So it can return multiple values. And this tells you whether or not it's inside, whether or not the lookup succeeded. So if it's true, that means that something else was in there. If it's not true, then it means it wasn't, right? And so the difference between this one and this one is okay, and for this one would be true, and for this one would be false. Okay? So just to show that, let's print them. Oops. So 0 false, right? And then if I search for something, 0 true. Okay? So for both cases, v is 0, but whether it's in there or not is true or false. Okay?
So what's v, sorry, what's v in that case?
V is the value that we're.
The value.
So for anything, it'd be 10. Right. So if I search for anything, v is 10. So it's for this version of, so you can either do a single value is going to return what it maps to, or the 0 value for the type. So for a string, it will return the empty string. For integer, it returns the 0. Or you can use this 2 value approach, right? And then you can use that to check. It turns out like each language makes its own decision about this problem. In C#, this throws an exception if it's not inside of it. That turns out to be really annoying because something not being in the map is very common. And so having to write try catch for your lookups is annoying. So it's kind of nice that it has this ability, but you can see how they work. So those are the keys. You can have keys that are of any type, right? So I can have an integer to integer map, right? So I can have 7 and 3. And then if we print x, we will have map where 7 maps to 10 and 3 maps to 0. So what's the difference between this and an array when it comes to like a map of ints to ints? Except in an array, if I create an array of 10 items and I set 7 to 10 and 3 to 0, there's all those other items that are 0. Okay? There's a bunch of blank spaces in it. But when I create a map, that's not true. Okay? In other